Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on tNavigator. It's a reservoir simulation software. tNavigator, it's very useful and it's very important for us to learn this software. And in this series, we will talk about CO2 geological sequestration. Okay, so in learning this, we will use model, default or template model from tNavigator. It's a tutorial file. So hopefully we can learn many things from this file. All right. So here we have our reservoir model, the grids. And currently we are looking at the calculated parameters, actually saturation of gas. All right. And in this particular video, we will not talk about the simulation itself. Later on, we will go to the script and we will learn many things from that. Okay, so let's start this video by running this. Click this button. Okay, you can see our wells, our injectors, and there are changes in the saturation of gas because we inject CO2. Okay, interesting. And then we can plot, and you see we are currently plotting the molar injection rate of component CO2, and the plot is molar rate in 1000 kilogram per day. Okay, kilogram mass per day, and this is the time, the date. Okay, we will elaborate more on this model, on this simulation, but in this video we will talk about the script. All right, so let's go to the script. All right, so this is the script. All right, script by the tNavigator. And you see, maybe in other playlists, I talk about the script, the usage of the script in reservoir simulation. And actually, the script is the most important thing behind the scene, behind the simulation itself. So in the background, actually the source of any information shown in the simulation in the user interface is actually the source comes from this, the script. All right, so yeah, learning to use the user interface is as important as learning this script. Okay, so that's why in this video, I will talk more about this one. So let's start. The first thing, oh yeah, there are keywords in the script. And keywords is the word that will activate something in the simulation. So you can imagine keyword is something like a button or a function that will be activated, that will be worked out in the simulation. Okay. And if we want to add comments in the script in tNavigator, you can use double dash like this, double dashes. Okay. So if you put double dashes before anything, it will be considered as comment. All right, it will be comment. So it's not comment. All right. So hopefully this is useful. Okay. The keyword, all right, is comment. Okay. Let me maximize it. Okay. Oh yeah. So we start with run spec. So this is very important. Make sure you start with run spec in the script. And title is a keyword to define the title. And the title for this case is supercritical state. And the name of the file made by the tNavigator is model underscore gas phase data. It's actually supercritical state case. All right. Hopefully in another series, we will talk about CO2 injection in liquid form, in liquid state. In this case, the CO2 will be injected in supercritical state. All right. And the keyword start, it means that when we will start the simulation, when we will start the operation, the injection, we start from March 2013. Okay. Okay, so you can follow me. I will zoom in again. Water. It's a keyword. It means the model, the simulation will contain water phase. Okay, actually we will inject the CO2 into an aquifer. So of course we will involve water phase and gas phase, all right? Yeah, we inject CO2 in supercritical state, supercritical phase, but in the simulation, it will be regarded as a gaseous phase rather than a liquid phase, okay? So gas will be the keyword. Comms, it's another keyword, and there is one and slash. By the way, you put slash to end any comment. So like this, the title, and then you close with slash. It means that the comment stops there, all right? And then the first date, you close it with slash. It means, yeah, you define the first date, and then you stop there, okay? And you say that comms, right? Number of components in a compositional run. We will involve only one component, which is CO2. And then we close with slash. Okay, that's just the rule in making the script for the simulation. Okay, especially for tNavigator in this case. And then metric, because we will involve metric unit. It's something like meter, kilogram, second, all right? And then end scale. The first thing, end scale. It's endpoint scaling of relative permeabilities and capillary pressure. Okay, so the modeling or the calculation for the relative permeability and capillary pressure, we will use endpoint scaling for the scaling technique. All right, so that's end scale. And then NODIR. NODIR here means non-directional endpoint scale. And reverse means reversible. Okay, and then demands 61, 97, 22. They are the numbers of grid blocks in X direction, Y direction, and Z direction. Okay, so the total grid blocks will be 61 multiplied by 97 multiplied by 22, which is, let me calculate using my calculator, 61, 97, 22, it will be 130,174. All right, and then tap dims, it's quite a lot. 2, 1, 20, 20, 9, 20, 1 star, 6, 4 star, 1 and slash. Okay, you can follow me. The first number, it's actually saturation function region. So we will involve two saturation function regions. Later on, when we go back to the simulation, it will be clearer, okay? And second number, only one, is the PVT region. So we will only involve one PVT region. There is no other region with different PVT. And then 20, it's saturation nodes in the table. So if you have table, there will be 20 values. Okay, that's good. And then 20 again, it's for the pressure node in PVT table. Okay, you don't want the values to be, yeah, just only 5 values, but you also don't want the values to be too many, 100 values in the table. Okay, it will be very, very crowded. So 20, it's optimum number. And then the fifth number, 9, it's actually fluid in place region. And then 20 again, sixth number, it's nodes of oil vaporization in PVT table. Okay, and then 1 star, it means nodes of oil and gas ratio in PVT table will be based on default. Okay, will be based on default. And the default value, yeah, if you want to know the default value, you need to go to the manual. Unfortunately, in this video, I will not be able to show the manual. Okay, so if you have tNavigator with you, you can read the manual. Okay, but hopefully this video will make it simpler for you. And then 1, 2, 3, 4, 5, 6, 7, 8. The eighth number is saturation endpoint versus temperature table, 6. And then it's 8 and then 4 star. It means that the number 9, 10, 11, and 12, they are 4, right? Four numbers will be based on the default values as per the manual. Okay, so that's what it means by star. Okay, and then 1 rock table for the last number. And then, of course, we close with slash. And then rec dims. It's number of regions with different parameter values. Okay. And then we have 4 values. The first one is fluid in place regions. It's 9. You can compare it with tap dims. The fifth value, the fifth number, which is again fluid in place regions. And then the second number in rec dims, it's families of user defined fluid in place region. And then 2 zeros. The third value is independent reservoir region. There is no independent reservoir region, and there is no defined flux region in our simulation because we have 2 zeros here. And then well dims, its dimensions for well data. We have 5 or 4 values here. The first one, 269, is the maximum number of wells. It's actually not that necessary to use or to put exactly 269. Okay. 53, maximum number of connections. 210, well groups, maximum number of well groups. And 17, maximum number of wells in one group, in each group. And then EQL dims, it's the dimension for equilibration tables. Okay, equilibration is very, very important for the simulation. So hopefully later on, we will go back to this equilibration table. And we have 5 values. The first value is the number of equilibration region. We only have 2 equilibration regions. And then 100 is the number of depth nodes in table pressure versus depth. And then the third number, 20, is the maximum number of depth nodes in any table RSVD. Okay, RS versus depth. Okay, I think it's very important if we can look at the simulation, the interface. But yeah, I will focus on the script for this particular video. Let's hope or let's be patient until we go back to the user interface. And then the fourth, we have maximum number of tables of initial tracer concentration versus depth. Let's use 1, okay. And then fifth, the maximum number of lines in table of initial tracer concentration versus depth. Let's use 20, okay. And then the EQDIMS, its dimension for the aquifer. We have 4 zeros. The first one is maximum number of lines of numerical aquifer data. We don't need that, put 0. And then second one, maximum number of lines of connection data for numerical aquifers, again 0. Maximum number of influence tables for Carta-Tracy aquifer, use 0. And the fourth value is maximum number of rows in a Carta-Tracy aquifer influence table. It's not relevant, put 0. And the fifth number is maximum number of analytic aquifer in the model. Let's use 3, maximum number of analytical aquifer. Okay, if any. And then, wow, 36,198. It's the maximum number of grid blocks connected to any single analytical aquifer. Okay, we're talking about number of grid blocks, so it's not surprising if we find a huge number like this. All right, and then VFPP DIMS. It's the dimension for the VFP table for producer. So VFP, vertical flow profile, I think, and then P for the producer and DIMS for the dimension. We have 6 values. The first one, 60, is the maximum number of flow values in each table. Second one is the maximum number of tubing head pressure, THP, in each table. It's good. We have 16 numbers, maximum. It's a maximum, by the way. It's not you have to put 60 value. No, it's just the maximum number. And then the maximum number of water fraction, something like water cut in each table. And then maximum number of gas fraction. In each table, we use 1 because, yeah, we inject purely in gaseous phase or supercritical in this case. So the gas fraction, there will be only 1 value, single value. And the fifth number, it's the maximum number of artificial lift quantities in each table. Okay. And maximum number of VFP tables for producer. 100 VFP tables. So it's like maybe you can create 100 scenarios for each producer. Okay. And then grid ops. It's options for grid data processing. Yes, if the keywords specifying multipliers are used. Yes, we will use multiplier. So we use yes there as the keyword. And then 10, the maximum number of multnum regions with the multiplier. And then, yep, CO2 sol, it's the main thing, the special thing in this case, because there will be solubility of CO2 into the water, right? We will have aquifer or water zone. In this case, we will inject our CO2 into a water zone, and we expect that there will be dissolution of CO2 into the brine, into the water. So we will activate that, that calculation using keyword CO2 sol. Okay. Solution in the brine or the water. Okay. And then unifout. And then for the grid, okay, we will not describe or we will not define the dimension of the grid within this script file because the script file will be too huge. So we will use include. And we use first tick this one and then type include and then slash and then the name of the file for the grid. In this case, the name of the file is subsurface underscore model underscore grid dot enc or include. So you close with this and then you close again with dash or slash, I mean. So what it means is that you will take the grid file from this file, subsurface underscore models underscore grid dot inc. Okay, so you don't need to describe the grid here in this body, in this file body. Okay, so you will look, you can have the script about a bit tidy like this one. Okay, it will help you later on. And then props, again you have grid, of course you have grid properties, and you will include that using this typing into using this scripting. Include underscore no, include slash subsurface model props dot inc. So the property will be taken from this file, and by property here means something like porosity, saturation, thickness, maybe permeability, not maybe, of course, permeability in X, Y direction, Z direction, right? So you will take the values, you will take the properties from that file. And the same thing with regions. So you will play with some regions in the simulation, and the regioning, the regions will be taken from this file. And for the solution, taken from this file. And for the schedule for your wells, for the injection, will be taken from this file. Okay, and yeah, later on in the next videos, I will show you each of this file. Hopefully we can learn something also, many things from those videos, those future videos. All right, and lastly, don't forget it, univout. It's actually to save calculation results as E1 E3 binary files. It's Eclipse E1 E3. Okay, and then it sets the mode of the output for restart and summary files. Okay, so of course, in simulation, summary and restart files will be produced, and the setting will be based on initially using univout keyword. All right, so I think we can stop here. The first thing in the simulation for our series is the scripting. And the first gate for the scripting is what we learn in this video. Okay, and in the next videos, hopefully we can learn something from this file, and other files. Until lastly, we will go back to the interface. All right, so that's all. I hope you enjoyed this video. I hope this video useful, and thank you so much for watching. See you again in the next tNavigator for CCUS modeling videos. Thank you.